In this video, we want to compute a limit of a sigma notation that is a little bit involved, but the process is the same as usual. So the first thing here that we want to do is express this notation, this summation here in closed form. That means without the sigma sign and without the counter, which is I in this case. So let's go ahead and do it. We have I equals 1 to n, 1 plus 2i over n quantity squared times, and I'm going to write this in yellow, 2 over n. Here we have two factors. We have this one and that one. And the second factor does not contain the counter. It does not contain I. So I can pull that to the front of the sigma notation. So this equals 2 over n summation I equals 1 to n of 1 plus 2i divided by n quantity squared. Now what we're left with here inside the sigma notation is an expression that needs to be worked out. So we have to express this in simpler form. What do we have? So I'm going to write just down here 2 over n summation from I equals 1 to n. So what we have inside the sigma sign is 1 plus 2i over n times 1 plus 2i over n. Remember that that expression is squared out, so you multiply times itself. So this becomes 2 over n in front still times, now we have to FOIL, and when you do that, when you FOIL, you get 1 times 1, which is 1, plus 2 times 1 times 2i over n, which is 4i over n, plus 2i over n times 2i over n. This is 4i squared over n squared, 4i squared over n squared. So that's what we have. Now remember, we can split this into 3 summation because we have 3 terms here. So this equals, we still have the 2 over n in front. We don't forget that. That's why I'm having it in yellow, a different color. So we're going to split this into I equals 1 to n, 1 minus sigma I equals 1 to n, 4 over n I, that's the second term, and then this should be plus here. It's the same plus that we have here. So plus sigma I equals 1 to n, 4 over n squared times I squared. So when we continue, this becomes 2 over n. So the first one, I'm just going to leave it the way it is for now. Plus, now for the second term, You see that 4 over n multiplies I, the counter, so we can pull that out of this sigma notation. So this becomes 4 over n, and then sigma I equals 1 to n I, and plus we can do the same thing for 4 over n squared. Here we pull out of this sigma. Remember, these are the linear properties of the sigma sign. So 4 over n squared, now sigma I equals 1 to n I squared. Now at this point we're going to use the properties or those formulas for the sigma notations. So we still have 2 over n here, and then parentheses. Now for the first summation, this expression here, we have 1, just a constant. There is no I here. So we're going to multiply 1 times n, and we're going to get n. So we're done with that. We move on to the next. Plus, we have 4 over n times, we know what this is. This is equal to n times n plus 1 divided by 2. And then we move on to the last term, plus 4 over n squared times, this is n times n plus 1 times 2n plus 1 divided by 6. So now we don't have any sigma or I anymore. But now what I'm going to do is I'm going to distribute the 2 over n, because it multiplies everything, to each term. So this will become what? This becomes 2n over n for the first, for this one. And for the second expression, what do we have? Plus 2 over n times 4 over n times n plus 1 divided by 2, and then the last term is 2 over n times 4 over n squared, and then times n plus 1, 2n plus 1 divided by 6. So that's what we have. Now we can simplify what we can simplify. For the time being, I'm just going to leave 2n over n here, and then plus, for the second part, I can cancel out the 2's. This 2 goes with that one, this n goes with that n. So I'm left with 4 n plus 1 divided by n. And for the last term, I can cancel this n with that one, and 2 here, I will be left with 3. So plus 4 n plus 1 2n plus 1 divided by, I have the 3 that remains here, 3 times n squared, so 3 times n squared. Now we can simplify further if we want to, but I'm just going to stop here for the closed form. Why can I stop here? Because remember, we've done a lot of computations here, but let's not lose sight of the fact that we wanted to compute a limit. So let's compute the limit of this term. We're going to compute then the limit as n approaches infinity of 2n over n plus limit as n approaches infinity of 4n plus 1 over n, and plus limit as n approaches infinity of 4n plus 1 to n plus 1 over 3n squared. Now we know how to compute limit at infinity. The first limit here, we can just cancel out the n, and we are left with 2 for the first one. The second one, the highest monomial, I'm just going to pick the second one here. The highest monomial of the top is 4n. So 4, so the monomial that has the highest exponent of n is 4n for the numerator, and that of the denominator is n. So when you cancel, you're left with 4. So the second limit is 4, and then plus. For the third limit, we do exactly the same thing. This third limit here, the monomial with the highest exponent of n is what? We have to be careful here. It is, so we have 4, we have n, and we have 2n. So we're going to multiply all these together, and we will get 4n times 2n, that's 8n squared, divided by the denominator, which is 3n squared, because we only have one term on the denominator. So this gives us 8 over 3. 8 over 3. So that limit is everything that you see here in white that I'm circling in yellow. So you have 2 plus 4 plus 8 third. So the limit at the end of the day is 26 thirds. So this is the final answer. Now, what I want you to do to practice this is to compute, so problem, compute limit as n approaches infinity of summation from I equals 1 to n of 1 minus 3i over n quantity squared, and then times 3 over n. So if you follow exactly what we just did, you should be able to find the solution without much difficulty.